The impossible, the unthinkable. Information is choice. Part 1, Information versus Reductionism, by Robert Johansson. A presentation prepared for the International Society for the System Sciences, Conference 2021, July 12, 2021. In 1948, Norbert Wiener wrote, "Information is information. It is not matter or energy. No materialism that does not admit this can survive at the present time. The materialism that does not admit this is mechanistic reductionism, the belief that all phenomena can be reduced to matter and energy processes or mechanisms." Mechanistic reductionism is based on Aristotelian metaphysics, developed by the monks in the Middle Ages. Everything in the universe consists of substance and form. It argues that substance is really real because it does not change, and forms or accidents are not real because they change. Thus, a lump of clay can be shaped into a cup or a bowl or a sculpture. The clay remains the same, but its form can change depending on the choice of the potter. Thus, the bowl is only real because the clay is real. By extension, matter and energy are real because they are universal constants. Therefore, these processes can be described with equations. But information, because it is form, is subject to change, and thus is not considered objectively real. With the advent of Newtonian mechanics, this became science dogma. Since only matter and energy were real, and they could be described with mathematical equations, therefore the world was merely a mechanism, and all phenomena could be reduced to a mechanistic formula. The advantage of this kind of metaphysics is immediately obvious. It makes the world predictable. The wonder of Newtonian mechanics was that by the use of equations, one could accurately predict the future. F equals ma, E equals mc squared, Ke equals mv squared. It allowed the space program to put a man on the moon. It is a short step from there to saying that since matter and energy are the only really real, then everything real is made up of matter and energy. And since they are predictable, then everything that happens is theoretically predictable and thus determined. Everything remains the same until it is forced to change. To understand change, simply identify the forces that caused it. This is the basis of the scientific method. Develop an hypothesis. Design an experiment to test the hypothesis. Do the experiment. Observe the results. The scientific method is a way to test a hypothesis, to see how accurately it can predict the results of an experiment. Does the hypothesis reveal a cause and effect relationship? The unspoken assumption is that all of reality can be described by cause and effect relationships, which can be expressed mathematically. This materialism is the basis of the Roman Catholic dogma of transubstantiation. The bread and wine of the Eucharist are transformed into the substance of the body and blood of Christ, but they retain the form, taste, and texture of bread and wine. Thus, although they taste like bread and wine, they are really the body and blood of Christ. Empiricism has always had a problem with this, on the general principle that if it looks like a duck, quacks like a duck, and waddles like a duck, it's a duck. There is an empirical definition of information that is not dependent on Aristotelian metaphysics. There are numerous definitions of information to suit various uses, but the information Wiener is referring to is information in the cybernetic or communications context. In telecommunications and computing, information is a choice. The empirical definition developed at Bell Labs is that information is a message selected from a set of possible messages. In the original, selected from a set is in italics. For example, given the 26 possibilities of the alphabet, the choice of an M is information. The information is the choice. The classic formula for quantifying information is the formula H equals N log 2S, where H is the quantity of information in bits, N is the number of symbols, log 2S is the logarithm to the base 2, rounded up, of S, and S is the number of symbols in the symbol set. The logarithm to the base 2 counts the number of binary choices it takes to code the information. In telecommunications and computing, information is a choice. It's important to note that there is no matter in grams or energy in watts. Also in this definition, there is no meaning. The count refers simply to the number of choices. The meaning of the information is the set that the information is chosen from. Thus, the letter M has no meaning in itself. Its meaning comes from being part of the set of symbols that is the alphabet. The cyberneticist Gregory Bateson, in his famous Korzybski lecture, defined information as a difference that makes a difference. Like Wiener, Bateson's information is not matter or energy. A difference is neither matter nor energy. Bateson's definition of information as a difference also has no meaning. The basic unit of difference is the binary either or, which is also the basic binary unit of choice. A difference that makes a difference is a convoluted way of describing a choice. It makes a difference because it is chosen or selected. The team at Bell Labs, of course, won the Nobel Prize for the invention of the transistor. The problem for Bell Labs was to come up with a way to automate the numerous switches needed in a telephone exchange. A transistor can be used as a gate with two possible states, open or closed. Thus, a telephone number is a set of choices that can act as a series of commands that activate a number of transistor gates. Any complex choice can be coded as a series of binary choices, usually symbolized by 0 and 1. Thus, in ASCII, A equals 0, 1, 0, 0, 0, 0, 0, 1. In a computer, choices can be stored in the binary state of a transistor. The choice of state is the information, and it is measured in bits, the number of binary choices. Modern science has recognized the problem of choice in a number of ways. The advent of statistical analysis has made prediction more complicated, but the goal of prediction remains the same. The statistical discovery was that if a specific variable in a specific set tends to have a distribution that follows a Gaussian or bell-shaped curve, then it can be considered a random variable. Therefore, it is possible to make a prediction for the distribution, if not for the individual elements. This allows people to make money on games of chance or quantum mechanics. The deterministic assumption remains that if the distribution does not in fact follow the probability curve, then it is not a random variable and is being controlled by some causal process. And once again, the unspoken assumption is that since only matter and energy are real, then it must be some form of energy process. Since both information and statistical probabilities are calculated from a set of possibilities, there is often confusion about the difference. Some people even think that information is a probability function. The difference is that information is measured in bits and probabilities are measured in fractions. Thus, a coin has two possibilities, heads or tails. The probability that it will turn up heads is 1 out of 2, or 0.5. Similarly, the probability of it turning up tails is 1 out of 2, or 0.5. If you flip the coin, it will turn up either heads or tails. Heads you can code as 1, and tails you can code as 0, which is 1 bit. A difference makes a difference because it is chosen. For cybernetics and telecommunications, information is objectively real. A choice once made is not a possibility but a fact. Thus, with the toss of a coin, before the toss there are two possibilities, heads or tails. After the toss, the resulting heads or tails is a fact. The choice is objectively real. Before having breakfast, there are possibilities, porridge or eggs. After the egg is eaten, my breakfast is a fact. Gamblers could place bets on what I'm going to have for breakfast tomorrow. If it's Sunday, then a mushroom omelet is a good bet. But I could change my mind. It's my decision. Thus it is probable, but not determined. Last Sunday I had porridge. Choice refutes determinism. In Newtonian mechanics, everything can be described in terms of quantities of matter and energy, and can be described in mathematical equations, because matter and energy are universal constants. The striking thing about Newtonian mechanics is that everything remains the same until it is forced to change. Thus, to understand change, the mechanistic thinker looks for the forces that caused it. But if actions are also the result of choices, then the future is not perfectly predictable, but depends on decisions that haven't been made yet. Choice is a challenge to the scientific method. The scientific method is a way to test a hypothesis to see how accurately it can predict the results of an experiment. Does the hypothesis reveal a cause and effect relationship? The presupposition is that the universe is a mechanism of cause and effect. But if actions are also the result of choices, then the universe is not a deterministic mechanism, and the future depends on decisions that haven't been made yet. The scientific method, instead of being the road to all truth, becomes a useful method for identifying some cause and effect relationships. If information is a choice, then scientific knowledge is not the rational understanding of objective truth, but only models chosen for various reasons to illuminate specific aspects of the environment, and subject to change. The advantage of the modern definition of information as choice is that it is clear, simple, quantifiable, useful, and gives us a basis for understanding holistic systems. But it means relegating mechanistic determinism to the dustbin of science.